So yung unang lesson natin is ocean energy or tidal power stations. Okay. So yung ocean energy description is tidal power or tidal energy is harnessed by converting energy from tides into useful forms of power, mainly electricity using various methods. So yung tidal power daw, na ko-convert niya yung energy ng galing sa tides sa iba't ibang electricity. Yung next. Working principle naman ng ocean energy or tidal energy. Tidal energy is created using the move of our tides and oceans where the intensity of the water from the rise and fall of tides is a form of kinetic energy. Tidal power surrounds gravitational hydropower, which uses the movement of water to push turbine to generate electricity. So ginagamit yung water para ma-push yung mga turbines para magkaroon ng electricity. Next, yung cause and frequency of tides. Ay, wait lang. High and low tides are caused by the moon. So, high and low tides daw, na-apektuhan siya dahil dun sa moon. The moon's gravitational pull generates something called the tidal force. So, the tidal force causes the earth and its water to bulge out on the side closest to the moon and the side farthest from the moon. These bulges of water are high tides. Then most coastal areas, with some exemptions, experience 2 high tides and 2 low tides every lunar day. Hindi katulad sa solar day na kasi yung lunar day is 24 hours and 50 minutes. Then because of the rotation of the earth through 2 tidal bulges every lunar day, coastal areas experience yun nga yung 2 high tides and 2 low tides every 24 hours and 50 minutes. High tides occur hours and 25 minutes apart. So it takes 6 hours and 12.5 minutes for the water at the shore to go from high to low or vice versa na from low to high. So ito yung frequency of tides. Yung kunwari yung moon nandito siya. Paano ba ito? Yung sa may video kasi ni Sir, pag tumaas yung pag umikot yung moon ng pag ganito, pag tumapat na dito yung moon sa low tide, then low tide na siya. Tapos ikot lang siya ulit. Kaya nagkakaroon ng ano. Ito nga sabi, as the moon position changes, 2 tidal bulges rotate around the Earth. So iba-iba every location ng oceans or yung mga tides. These bulges represents high tide. Next naman yung cause on frequency of tides. If high tides are caused by the gravitational pull of the moon on Earth, so why there are high tides on the side of the Earth opposite of the moon. The high tide on the side of the Earth facing the moon is called the high tide. So yung side daw ng Earth, pag naka-face siya sa moon, yung nangyayari doon is high tide. The high tide caused by the bulge on the opposite side of the Earth is low high tide. A low high tide may be understood as the moon's tidal force pulling the planet, not the ocean, towards it. Okay. Next, on the side facing the moon. The gravitational attraction between the Earth and the moon is strongest on the side of the Earth that happens to be facing the moon simply because it is closer. So mas malapit daw siya yung moon. This attraction causes the water on this near side of Earth to be pulled forward the moon. As gravitational force acts to draw the water closer to the moon, inertia attempts to keep the water in place. But the gravitational force exceeded and the water ID pulled forward the moon, causing a bulge of water on the near side forward the moon. So tumataas nga yung water dahil dun hinihila ng gravitational pull ng moon. On the opposite side of the Earth, or the far side, the gravitational action of the moon is less because it's farther away. Mas malayo naman siya sa moon yung opposite. Here, inertia exceeds the gravitational force and the water tries to keep going in a straight line, moving away from the Earth, also forming a bulge. Gravity and inertia act in opposite on the Earth's ocean. creating tidal bulges on opposite sides of the planet. On the near side of the Earth, the side facing the moon, the gravitational force of the moon pulls the ocean. Water forwards, creating one bulge. On the far side of the Earth, inertia dominates, creating second bulge. Next yung types of tidal power. Next.
Okay. Types of tidal power. Ang kaunahan po is yung tidal stream generator. Tidal stream generator are very similar to wind turbines, except they are below the water surface instead of above or lead. The water's current pushes the blades of the turbine, which is connected to a generator that creates electricity. Yung tidal stream generator pala, similar pala siya sa wind turbines. Kaso nga lang, yung tidal stream generator, makikita mo siya sa ilalim ng tubig. Tidal stream generator are able to produce much more electricity than wind power plants, mainly because water is much denser than air. However, water's high density also means that tidal turbines need to be much stronger than wind turbines, making them more expensive to manufacture. Tidal stream generator turbines are large, but they create relatively little disruption to the ecosystem around them as compared to tidal barrage. The world's first tidal stream generator was constructed in 2007 at Strangland Loop in northern Iceland. Next po. Makikita po natin yung susunod na largest tidal power station. Ang nanguna po nga dito is yung Shiwa Lake Tidal Power Station na matatagpuan po sa South Korea. Next po. Sa picture na po ito, makikita po natin na puro horizontal lang ginagamit nilang turbine. Pero mamaya makikita nyo po yung iba't ibang klase po ng mga turbine na ginagamit sa tidal stream generator. Next na picture. This is the tidal stream generator na makikita nyo po sa ilalim ng karagatan. Tidal stream generator. Types of turbines used in tidal stream generators. HAWT or horizontal axis wind turbine, then BAWT or vertical axis wind turbine. Sa una, yung BAWT, makita nyo dito na Sarbonese turbine, bihira po natin siyang makita. Pero nagagamit pa rin po siya sa tidal stream generator. Ang palaging ginagamit po natin sa tidal stream generator is yung horizontal axis wind turbine o yung naka-horizontal po na turbine. Yung pangatlo po, ginagamit din po siya pero di po siya ganong ginagamit po talaga sa tidal stream generator. This is the first tidal stream generator. Makikita po natin sa picture na to na may dalawang parang pakpak po siya. Ba't po may ganun po? Ba't may tali doon sa dalawang pakpak na yan? Yung turbine po kasi, pakibalik po sa picture. Yung turbine po kasi makikita nyo po sa dalawang mahabang kamay ng tower ng isang tower na po yan. Ngayon po, kaya po siyang itaas at kaya po siyang i-submerge. Ba't po siya tinataas? Para po sa maintenance. Ito po yung kanang-unahan na tidal energy generator. Next picture po. Ito na po siya yung naka-submerge na po yung turbine po niya sa ilalim ng dagat. Second type of tidal power is tidal barrage. Tidal barrage are low-walled drums usually installed at tidal inlets or estuaries. Pag sinabi mong low-walled dams, ibig sabihin, di ba yung dams, pag nakakita tayo ng dams, napakataas po niya. Ito po yung low-walled dams, ginagawa po ito malapit po sa coastal area ng karagatan. siya po yung nagbablock po sa coastal area. Siya po nagbablock po na siguro po 1/4 na papuntang coastal area. Okay? Similar to traditional hydroelectric dams, sluice gates are used to create a reservoir on one side of the barrage. The barrage is secured to the seafloor, while the top of the barrage is just slightly above where the water level hits during highest tide. Tidal turbines are located towards the bottom of the barrage inside a tunnel which allow water to flow through. Di sa huling na sinabi po niya, para nga po siyang drum. Ay, para po siyang dam. Yung pagka-function po niya. Itong picture na po to is yung Rance Tidal Tower Barrage Fence. Pakita nga po yung, ito po yung bird view po siya. Makikita po natin sa dalawang dulo po, wala po makikitang kahit anong daluyan ng tubig po. Talagang baradong-barado po siya. Ito po yung tidal barrage na tinatawag po. Next sa picture po, ito yung Shiwa Lake Tidal Power Station. On his bird view, next picture po. Ito po yung bird view ng Shiwa Lake Tidal Power Station. Talagang wala po siyang piyapalusot na tubig po. Gano'ng kalayo po niya, hindi po piyapalusot. Next po. Tidal barrage flood generation. Ito po yung kung paano gumagana yung tidal barrage. Pero mamaya po mapapakita naman po sa video kung paano po ito nag-function. Next po. Ito, kasama pa rin po sa tidal barrage po ito. Tidal barrage look like traditional hydropower dams. Turbines located toward the bottom of the barrage are turned with the incoming and outgoing tides. During an incoming high tide, water flows over the turbine and the water rises. Then the water flows back through the turbines as it becomes low tide. The turbines are connected to a generator which produces the electricity. Ibig sabihin, sa tidal barrage po siya, pag nagkaroon ng high tide, magpa-function yung tidal barrage, magbubukas ng dalawang gate. Ngayon, yung sa high tide po, papasok po siya doon sa coastal area. Ngayon, magpa-function po ngayon yung turbine doon sa ilalim ng tidal barrage. Ngayon po, pag nagkaroon po yung low tide, pag nagkaroon po ng low tide, ibig sabihin, bababa yung karagatan. Pero yung sa coastal area, mataas po, magba-backflow lang po siya papuntang karagatan. Yun ang nangyayari po sa tidal barrage. After a construction phase lasting 5 years, the Rance Tidal Power Station was opened on the 24th November 1966. This was the first power station to take advantages of tidal water flow to produce electricity.
The tidal lagoon. A new tidal energy design option is to construct circular retaining walls embedded with turbines that can capture the potential energy of tides. The created reservoirs are similar to those of tidal barrage, except that the location is artificial and does not contain a pre-existing ecosystem. The cancelled tidal lagoon Swansea Bay is walls in United Kingdom would have been the first tidal power station of this type of once back. And ang tidal lagoon naman hindi na ito natural ang tidal lagoon. Ito na isang man-made, and dito sa mundo natin theory pa lang dito sa mundo. Hindi pa pero ito na ay isang proven na sa itetest na nila dito sa atin. Yung parang malit pa lang ganun, yung na-proven na talaga. Next. Yan yung image niya ng tidal lagoon. Diba? Isang man-made na yan, no? Nakikita.
the restless tides, flowing in and out 4 tides a day. A firm thinks it's time to harness all that energy.
This is Swansea Bay, Wales. The tidal range here is enormous.
The firm plans to build a sea wall over 5 miles long to enclose a vast body of water into a lagoon here in Swansea Bay. Large power generating turbines will be set in the sea wall. Here's how it works. On the left here is the open sea, its height increasing from low tide to high tide. The sea wall holds the rising tide out of the lagoon on the right. Then a wicket gate is opened to let the high tide flow in. That makes electricity. When the lagoon fills up, the tide goes out and the whole process is reversed to make energy once more. We're about 1.5 miles out to sea now, and it's right down beneath me that the turbines will go. And you can see the vast amount of water that will be held back by that wall.
The motion of tidal lagoons is let's use that free power created by the dance between the moon and the planet, and let's generate electricity for the next 120 years. Very certainly, a little bit expensive to start off with, very cheap for a very long time.
Environment groups say the lagoon shouldn't disturb wildlife too much. They say it'll make much needed clean energy. There's one great thing about tidal power. Unlike energy from the sun or the wind, it is utterly predictable. So from here at high tide to way down here at low tide, engineers can calculate exactly how much water has been moved and exactly how much energy that will generate. And the power firms really value that certainty. But one group is concerned, the anglers. What about the impact of the lagoon on local rivers?
We're very worried about tidal lagoons because they have the potential to chop up lots of fish. And the positioning of lots of lagoons near the mouth of rivers is very alarming for us.
There's another drawback. The lagoon will have to be subsidized by field payers, and it is looking very expensive. The developers claim a second lagoon they want to make at Cardiff will provide energy for about the same cost as nuclear and much more safely. Ministers are committed to getting almost all our electricity from low carbon sources. They hope a fleet of lagoons round the coasts of Britain will prove affordable as well as reliable. Roger Harriman, BBC News, Swansea.
Okay.
Yan yung kwan natin ng tidal lagoon. Kung paano mag-operate. Okay.
Next.
The advantage of tidal energy. First is renewable. Tidal energy is a renewable source of energy, which means the energy does not deplete as is used. Ito naman ang renewable, hindi na ito nauubos. Nandito lang sa atin yan, yung palagi na nakikita natin from the word renewable. Yung next naman is zero carbon emissions. In addition to being renewable energy source, tidal power stations do not emit greenhouse gases during electricity generations. Ito naman yung hindi ito nakaka-harm ng environment at sa mga tao. Yan from the word zero emission na nga, di ba? Zero carbon, yung wala nang nilalabas na na harmful. And the predictable. Predictable is a tidal current are highly predictable. Low and high tides follow well-known cycles, making it easier to know when the power will be produced throughout the day. Ito naman yung from the word, ito yung ikon natin yung predictable. Yung nasa tamang oras ito, kung ano yung mga nagpo-forecasting, kapag nagpo-forecasting sila, yung mga utility ng mga power plant, ito yung exact talaga, yung hindi talaga lalagpas ng oras ganito. Kagaya sa wind natin. Kasi sa wind, hindi yun exact. Kasi nga, yung wind, hindi natin makontrol yung wind . Kasi iba-iba yung pagkuan ng wind sa ating and kagaya sa West M sila yung nagkakuan doon, tumitingin dito sa sa Pilipinas. Basta search na lang po sa West M. Merong makikita doon sila mismo. And yung high power output naman. Ito yung tidal power plants are able to produce high amounts of electricity. One of the main reasons for this is because water is dense, almost 800 times more dense than air. This means that is a tidal turbine will produce substantially more energy than a wind turbine of the same size. Siya na yung pinakamataas ng advantage of tidal energy. Siya na yung pinakamataas. High nga. Next. Next tayo. Next slides. Yan naman. Sa disadvantage of tidal energy. Limited installation sites. In order for tidal power plant to be built, the potential installation site must meet very specific requirement. First, they need to be located on a coastline, which limits potential station sites to the control site. There are additional requirements a potential site must meet. For example, tidal power station need to be built in a place where the difference in height between high and low tide is significant enough to power turbines. This limits where the power stations can be installed, making it difficult for tidal power to be implemented widely. Yun lang naman, ito lang naman yung from the limited, isa itong limited lang na pinapatayo. Kasi nga, next, makikita nito yung next slide, yung expensive nga, expensive. One of the biggest drawbacks of tidal power is the high upfront cost. Tidal energy turbines need to be much sturdier than the wind turbine because of the high density of water. Most of the tidal power plants that are currently in operation are made of tidal barrage. The construction of tidal barrage is extremely expensive. The Rance power plant was expensive to build in its day and took about 20 years to actually pay for itself. This is one of the major reasons to propose Severn Barrage has not gone ahead. Yun nga, ang tidal barrage na ito ay napaka-expensive. Kagaya dito sa Rance power plant na sino naman mag-i-invest ng 20 years bago makuha yung puhunan, di ba? Napaka-expensive, malulugi na tayo doon. Siyempre, hindi natin makukan yung kita natin doon, napakatagal na pagpasok ng pera doon. Hindi natin makukuha agad, hindi tayo yaman agad din. Siyempre naman, yun lang naman yung way natin para yayaman dito sa mundo, yung mabilis ang pera, eka ni Sir. Next. Yung disadvantage of tidal energy in environmental effects. Tidal barge disrupt the natural flow of water in and out of the estuaries. This can have an effect of marine life, disrupting life cycle and so spawning. Underwater turbines have the potential to kill marine life, much like wind turbines, like birds. This concern is valid amongst all tidal power plants, but larger marine life is likely to only be affected by tidal extreme generators. In Rance, since the tidal barrage construction needed to drain the estuary in the initial years after the construction was completed, there were severe impacts to the local environment. However, 10 years later, it was considered that the Rance estuary once again had a rich diversity of aquatic life. After the seawall was built in 1994, population built up in the newly created seawall lake reservoir, making its water useless for agriculture. Concentration of perfluoroctane sulfonate or PFOS measured in Lake Chewa were among the greatest ever measured on the environment. ito naman nakaka-disrupted talaga ito sa mga kagaya sa mga seawall lake. Namamatay ang mga marine life in mga animals, mga ganun, marine life, and kagaya naman sa sa runs yon. Isa din ito na napakadelikado pero nabago na sa technology and nagagawa na nila ng paraan para mabago yung maging maganda na yung mga marine life nila doon. Kasi napaka-kwan natin doon sa tidal energy sa lagoon. Yung napakadami nilang nasira noon talaga from sa water na pumangit ng agos, mga ganun, dumumi. And next slide sa future of tidal energy. Yan. Tidal energy has the potential to offer all the power we need, eliminating the need for fossil fuel. As started by CIMEC Atlantic Energy, the tide moves a huge amount of water twice a day. Harnessing it could provide a great deal of energy, around 20% of Britain's needs. However, as tidal technology has only been available for a few decades, many challenges remain. British companies and universities are currently developing a new wave of technology supported by grants from yung 50M and yung basta yan. Marine of Renewable Deployment Fund. Almost 10 years ago, the Southwest Regional Deployment Agency installed the Web Hub, the most technology sophisticated and open access dive for testing renewable technologies 14 kilometers of the Cornwall coast. Another company also making a splash in the United Kingdom in the European Marine Energy Centre EMEC in Orkney. Yan nga, future, yan na yung pinapakita na future ng tidal lagoon. Okay po, sir. Thank you.
Okay. Thank you po.